Beyond Nucleus and Electrons, a space-filling matter perspective on atomic structure. One introduction. The conventional model of the atom describes it as a small, dense nucleus surrounded by electrons, with the intervening space considered empty. However, if the concept of space-filling matter, an ultra-thin, invisible medium generated from cosmic mass defects, is correct, then this empty space is a misconception. Every point in space, including the interior of atoms, may be saturated with this unseen substance. 2. Origin of space-filling matter. Mass defects occur in extreme astrophysical events such as stellar fusion, supernovae, and neutron star collisions. According to this perspective, these defects are explosively converted into a form of matter so fine and evenly distributed that it permeates the entire cosmos. This medium, though invisible, would exert physical effects wherever it exists. 3. Presence inside the atom. If space-filling matter exists everywhere in the universe, it must also exist within atoms. Thus, an atom may not simply be a nucleus and electrons in empty space, but a composite of 1. Nucleus, dense, positively charged, containing most of the atom's mass. 2. Electrons, negatively charged particles situated in resonance positions. 3. Space-filling matter, a structured density gradient that influences electron placement and motion. 4. Revisiting Rutherford's model. Rutherford's gold foil experiment demonstrated that atomic mass is concentrated in a small central nucleus. However, the familiar picture of electrons constantly orbiting the nucleus is a conceptual construct. There is no direct experimental proof of continuous electron motion in fixed paths. Instead, electrons may be better understood as occupying resonance positions influenced by 3 primary forces: nuclear attraction, buoyancy from dense inner space-filling matter, mutual electron repulsion. 5. Interaction with background energy atoms in nature are constantly exposed to various energy backgrounds, including conduction, energy transfer via contact with matter; convection, energy movement through fluid motion; radiation, energy carried by electromagnetic waves. Complete isolation from these energy backgrounds is practically impossible. As a result, electrons respond to the intensity of external energies by entering excited states. 6. Photon emission and energy state diagnosis. When atoms are exposed to high-energy environments, they emit a wide range of photon wavelengths, both short and long. Under low-energy conditions, they emit only long-wavelength photons. Long wavelengths only, outer electrons excited, inner electrons nearly at rest. Short plus long wavelengths, multiple electron layers excited. The emitted photon frequencies are direct indicators of the electron's vibrational frequencies, which in turn reflect the degree of external excitation. 7. Spectral fingerprints and resonance analogy. Every element emits a unique fingerprint spectrum when excited and absorbs that same set of wavelengths when cooled. This is analogous to a radio transceiver equipped with multiple resonant columns. Each resonant column emits or receives only its specific frequency. Electrons behave like these resonant columns. Each position emits or absorbs photons at characteristic frequencies, matching its resonance. 8. Proposed structural model of the atom. In this framework, atomic structure can be summarized as follows. 1. Space-filling matter density gradient, highest near the nucleus, gradually decreasing outward. 2. Atomic radius definition, the point where internal density equals ambient cosmic density. 3. Electron configuration, determined by nuclear attraction, buoyancy from dense inner space-filling matter, and electron-electron repulsion. 4. Excitation dynamics. Excited electrons are displaced into outer, less dense regions by the denser inner medium. 9. Conclusion. This space-filling matter perspective offers a more complex and potentially more accurate picture of the atom. Instead of being composed of just a nucleus and electrons in empty space, the atom emerges as a 3-part system: nucleus, electrons, and an omnipresent structured medium, interacting to define its size, stability, and energetic behavior.